So guys, welcome to the module 2 of software development security domain A. And today we are going to discuss a little about DevOps and CICD and something more about a new upcoming trend, which is called as DevSecOps, right? So let's get ahead with that. So basically, what is DevOps approach? So DevOps approach is a software development approach wherein the development team and the operations team, they come together, right? Now, what happens is in software development, there is a different uh, perception what the development team has, and then there is a different perception with the operations team. So most often, the thing which is developed by the developer team sometimes is not matching the requirement of the operations. So there was a requirement for bringing in these two different worlds into the same parlance. And that is where the concept of DevOps came in. Okay. So the picture which you are able to see here, guys, this is how it is categorized here. Let me start my pointer. Okay, so whatever you see here, um, sorry about that. Why? Just give me. Hope this should work now. No, anyways, it's not working. So, guys, whatever you see here on the left side here is all related to the development team, and then what goes on the right hand side is for the operations team, right? So the thing here is to tell you that earlier these two spheres, they were separate. There was a lot of gap in there. So we need to bring in the development team and the operations team together. How do we do that? So it's a purely cultural change. It's a totally perception change when it comes to DevOps. So in this, what happens is there is a development team and there is an operations team which come together, work together, a team which is having members from both the side, so that they can collaborate much more effectively and then come out with something good. And to make the quality as the priority, they also have the QA team, few members from the QA team as well, quality assurance team. Okay, so they will keep on checking the quality of the product which is coming out. So how does it goes? And a lot of automation, because it's just not about bringing two teams together. It is also about bringing in more tools in there so that more automation is there in the process. Okay, so the first thing is where the software development start is with the planning phase, right? So in this planning phase, both the team will sit together. They will kind of in the requirement phase itself, they will come together and they will review the requirements. Once the requirements are finalized and reviewed by the team, all the members, then it will go for the development. That is where all the coding start happening, right? And we implement a lot of automation by tools like GitHub, because there will be multiple members of the team and they should not be working in silos. So what happens is, end of the day, whatever they do, they commit their changes onto the central repository. It can be a GitHub repository, it can be a Jira repository, or a Confluence repository. Right? So that is how the repository is kind of acts as a single base for all these things, right? Then once the code is finalized, then there will be some form of automation, maybe through Maven and tools like that, wherein the build will happen. That is where the code will be compiled. And if there are any errors, then those developers need to go and clear those kind of errors, right? And then once the build phase passes on, then there is an automated testing also which is involved, and very famous tools, open source tools like Jenkins, and other tools like JUnit or CodeShapes, these kind of like JUnit and those, or Selenium for that matter, right? It's a wonderful tool for software. And then when the testing is all done, all kind of testing has happened, then the software is released. Now, once the software is released, it goes into deployment. That means it goes into the production. So that is where the production can happen on different platforms. It can be on cloud like AWS, it can be on Dockers, containers, whatever we have nowadays. And then the team start operating on them. Once the team start operating on them, then also we are using different tools here like Kubernetes, Ansible, and things like that. And then at the same time, throughout the life cycle, throughout this life cycle of the deployment and usage or operations, we need to make sure that the software is monitored at all times. For example, you hosted some application over cloud, then there are like Watchdog and those kind of tools which will be having a constant uh, view. They will keep on monitoring transactions and any kind of access related thing or any violation in those policies, and all those things will be kind of captured by different tools like SIM or things like that. And then again, there is a cycle you can see here. So whatever shortcomings, whatever the feedback from here, it will go back again to the planning phase and things will be taken. So it is just not the integration of the development team and the ops team. A lot of automation actually goes back into the background, wherein the things are automated and they are so closely binded into that. Right? So as we see a lot of automation coming in, what how do we define that automation? How do we define a particular pattern? What need to happen first and what need to happen next? Right? And that is where, guys, the next concept comes in, which is called as CICD. Right? So CICD stands for continuous integration and continuous delivery. Right? We call it as CICD. So, like as you can see on the left hand side of your screen, that's a representation of the traditional way. There are multiple members in your team, development team. They go ahead and do some coding, and they are working on that coding, and there are various versions of that coding. And then finally, when the software is developed, that goes into the code base, maybe a central repository, and that is where the quality assurance activities like software testing and those kind of things happens, right? But the problem here is during the testing phase itself, if something comes out as a feedback, some kind of vulnerability like SQL injection or some kind of cross-site scripting or anything which is like maybe authentication bypass or those kind of things, then what happens is the team has to rework completely. Maybe they spent weeks together to work on a particular software and then collaborate that, and then the software is going for testing. That is not the most efficient way of doing it, because if anything comes back, then these guys has to go back, start from scratch and start doing everything again, right? So that is a lot of time wastage in that way. But if the testing is successful, then the software will go for development. So as we see, there is a lot of, this is not the optimized way of developing the software. What can be a better way is defining some sort of CI/CD, right? So that means the continuous integration. So what is continuous integration? That means on Monday, if you develop some kind of code, programmer A, programmer B, and programmer C, that goes into a central repository wherein hand to hand there will be automated pipelines which will be made. There will be a flow which will be defined into the repository like Jenkins and all. And then that testing and integration testing will be done by the tool itself. Even if the programmer is sleeping, but that pipeline is already defined, so that thing will work automatically, right? And then if there are any feedbacks, immediately the tool will send some email or kind of some notification to the developers, so that if there is something, some flow, something which is not getting integrated better, or if there is a software flow, there is a logical flow, the very next day the developer can go and fix that, right? And that brings a lot of value to the software development, correct? And likewise, as you can see here, multiple iterations keep on happening. It's a kind of continuous process. Every day, every sprint, you just whatever code you are developing, hand to hand, that code is being tested and all those kind of things, right? So after that, the what we see here is very less number of feedbacks. So that is a lot more optimization when it comes to software development. And then at the same time, when the software is tested, it is also goes into the build phase, wherein if everything works out well, it will again be deployed. It will again be delivered, right? And then how the development is actually being performed. So what you see here is there is a lot more automation which has come into the picture here, and we are utilizing very good tools, open source tool like Jenkins and all. These are definitely a very big plus to the software development, right? So that is how actually it happens. As you can see at the bottom as well, we build something, we test it, and then merge those changes with the with the software, right? And then there will be a continuous delivery. That means for the release, you don't need to do anything. That is also automated. It will be automatically released to the repository, wherein there may be some user acceptance test and all, and then it may go into the production. So that is the kind of model which is getting much more popular nowadays. For that, what you need to do is you need to go into your software like Jenkins and all, and then you need to define those pipelines, those automation pipelines, how the flow will work. And then if there is a feedback, then how that feedback is given back to the developers, so that very next day they are going to fix it and come back. This also prevents a lot of expenditure when it comes to the software development, because the very same day the developer is getting some kind of feedback, and then he acts according to that, so that when the final product is out, those things need not to be addressed because they are already addressed in the very early phase of the development. So this is how the entire continuous integration and continuous delivery things actually work, right? Now that we have discussed the DevOps, and then how in DevOps we are bringing in this kind of automation by means of continuous integration and continuous delivery, right? Let's now also talk about DevSecOps. So this concept is a very new concept which has come up. We already tried to bring in the development team and the operations team, and there is a lot more benefit out of it. Now, the question arises, how do we take care of security during this phase? So there will be few people from the security team which will also work with this group. And it's just not bringing people together, it is also bringing in some kind of touch points. So these touch points is where you need to bring in some kind of automation, and things are tested from the security perspective as well. Okay, just like when it is going through the planning phase, the security has to come in. The security team has to come in. They have to make sure that the things are adhered as per the security policy. And then security team is also involved in threat modeling. Threat modeling is just another type of risk assessment, wherein the team in a very proactive manner, they will go and map those kind of different threat vectors which will come and impact your applications. And based on that, the proper appropriate controls, those kind of things will be integrated from the planning phase itself into the software development, right? Now that the requirement is finalized, and the DevSecOps, all three teams, they all agree to that. Then the actual coding will start. So during the coding phase as well, there is a lot of testing which goes in, right? During the coding phase itself. That is called as the static coding. We already spoken about in the previous domain as well. What is static coding and dynamic analysis, right? SAST and DAST. So this is where we will implement some kind of tools. For example, there are some tools. For example, when the developer is actually developing some applications and he needs some kind of API or need to download some software component, maybe some open source component, there are tools which are available which will tell the reputation of that particular software component from the security perspective. So the tool here itself is not allowing the developer to integrate such a software component which is vulnerable, right? So that is how the code is tested. So the code is tested. There is a manual code review which happens, and there is a code analysis which happens, and parallelly there is something called as SCA, right? Software component analysis. Because normally the static testing focus only on the coding, what the developer is doing. But what about if there is some vulnerability into one software package which he called in, he integrated into that coding? What we do with that? So that is where the SCA things come in. The software component analysis also happens at this level. So that is how the coding, we make sure that the code is kind of secure during the development phase by itself. Okay. And then code review will happen, and then the software will now, the code will go into the build phase. So build phase is where all the compilation or the interpretation will happen. So those interpreters or those code builders, they already have some kind of security features which are there, and their threat intelligence is already kind of updated. So if any code during the build phase itself is not suitable, those tools will come and say to the developer, man, hey, this is where your code is not secure, right? And then the immediate feedback will be passed to the previous phase. It will go back to the coding phase. The developer will kind of improve on that, and then again submit that code to the build phase, and that is how the cycle will work, right? Once the build phase is now over, the next phase is the testing phase, wherein because we already did some kind of testing, if you remember, during the coding phase itself. Now also there will be some kind of testing which is called as dynamic testing. We call it as DAST. Okay, so this is where there will be some kind of testing or some kind of analysis which will be happening in runtime while the application is being run, right? So that is also wherein we bring in some sort of pen testing and tools like burp suit and all those, which will be able to find out if there are some vulnerability, and Selenium as well. Those tools are having that kind of capability. Right? Now that we are able to test the software and it is as per security is taken care of, then it will go into the release phase. Once it goes into the release phase, the next portion comes is the deployment. Now, during the deployment itself, we need to make sure that the appropriate logging of the application is enabled. And those loggings are also kind of audited or kind of counted. That means there is a continuous monitoring for these applications also happening. And then there are tools during the operation phase itself. When the software is getting worked upon, software is into production, then there is a continuous threat intelligence which the team will work out. If there are some kind of vulnerabilities which are coming in, those vulnerabilities needs to be immediately patched and all that. That will happen. And then there will be a continuous monitoring onto that particular application, business application, right, during the operations. And if there is anything which is detected, some kind of anomaly is detected, then there will be a response, immediate response. Maybe your SOC team will come back and say, this is what we are able to observe. And then the incident response things will work, right? That is how it goes into production. And then in some cases, if there is something which a software is completely compromised or something, then they will go and kind of fix those issues. They will try to recover that and things like those on those lines, right? Then finally, this monitoring phase is throughout the life cycle of the deployment. And then whatever the observations and the lesson learned from all these is then fed again into the planning phase of the software. Those requirements will again be kind of addressed, they will be brought out in the next release, and then the cycle will start working. So this is where it's a very high level of the DevOps, DevSecOps approach. Okay. Now, in software development, there will often be a lot of change, right? And any change has to undergo some kind of controlled environment. How do we do that? So what we do here is the team, which actually, for example, a particular software is now into operations, and there is some kind of bug which has been identified by the operations team. They will go ahead and raise a change request. Then that particular change request will be analyzed, and then based on that, there will be some kind of feasibility testing which will be happening, the kind of impact it has on the application that will be tested, and then the security team also will work out on some kind of plan on the timelines to fix this kind of right? And then develop implementation strategy. There will be a plan which will be rolled out, and it will go for some kind of approval. That there will be as usual, there will be change control board who will approve those. Then once it is approved, then the development team will go ahead and develop that particular change. And then it's not immediately rolled out. That particular change will go through some phase of implementation and testing before it moves into production. And then it is properly tested for effectiveness and review changes. Some kind of regression testing will happen. Regression testing is a kind of testing wherein any major change in the software has to go for a regression testing, so that the new change is not impacting the software in any sense, right? So that is where the regression testing will happen, and then the changes will then be reported to the management. So this is how we already discussed about the change management into other aspect also from the operations perspective and all. This is how it is dealt into the software environment. Okay, so that is how the entire cycle